Hi everyone. Today I'm going to be talking about continuous deployment with Python. My name is Natalie. I work at Vevo as part of DevOps team. I work as a software engineer, basically automating tools. You can write me an email. This is me@gmail.com. So let's start. So agenda for today's talk will be what is continuous delivery, why and how continuous delivery should be implemented, how we implemented continuous delivery at Vevo, and why we recommend it to other developers or DevOps engineers, what is actually delivery pipeline, and if there is a way to improve it, can we improve it, what can be improved. So let's start very simple. What is continuous delivery? So currently every probably startup, every company nowadays has continuous integration, and this became this kind of as a standard, the way how people deliver their code to production. Continuous delivery actually takes step further. What it gives, it provides ways of having deploying your application in any environment, so you're not dependent on environment, your test not dependent on any configuration that you can or might have. So continuous delivery is a capability of continually deploy software to production as frequent as needed. Basically, you should not have downtimes, or if you have a quick fix, you don't have to wait for particular time to do your deploy, to check up your code, and things like that. And the goal of continuous delivery is to enable constant flow of changes into production, and basically by using automated software production line. So why should we start doing this in our day-to-day jobs, right? So first we should improve speed to market. Basically, as I mentioned before, development should be able to deploy their code faster, which is the first paragraph. The second one, ensure the quality. Basically, the way how we do it is we can release our software faster and more often. Basically, if you have a bug, you just release it. You can just go back, revert, roll back, or fix it faster. The other point is our deploys are smaller. We don't have to roll on big monolithic app, or so that's why it's more easier. For example, if you're a company using a big monolithic app, as I mentioned before, it probably will slow down you, and you probably will have a downtime. So this way you can build your stuff faster and more agile. So in this presentation, I'm going to implement, I'm going to suggest how do you implement your continuous delivery following the pattern we implemented in our company and we're suggesting to others. There is also a coding piece. It's basically part of the workshop, which is way longer. So for now, we're going to talk about these pieces, and if we can have some time, I can show you more. So the things we propose in this pattern is to make your environment, your code actually more testable, which will be passed in every environment, and it also should be more deployable. Deployable meaning you can have your environment easy to set up, and you don't have to worry about any other dependencies. So it can be run on any workstation, or it can be run in any cloud solution, or things like that. Basically, what we did at Vevo, we tried to design our testability and deployability using the solid design pattern. I'm just going to leave it here, and you guys can research what is it. What it helps, it makes our software more understandable, flexible, and maintainable. We do use microservices, and this is one of the benefits, what can help you. So basically, let's talk why would we automate with Python in DevOps world. Like, there are multiple different languages. For us, we chose Python because there are many modules already available on the market. They open source. Examples like GoCD, Jenkins API, Python Jenkins, DockerPy, and things like that. Some of them, well, this will save you a lot of time. You can write your own. This is what we do. Sometimes we try to use any of the available ones, but then we have to scale, or we start noticing that some things get repeatable, and that's why we chose to do that. Also, what we're proposing to do is to have your pipeline available in your source code repository. What this will give you, basically, you don't have to go through pain of clicking UI or setting up UI. You can just have everything in, for example, in the file, and this way you can. It's very fast to recover, right? Because you know you can change just one line, commit it, and fix things that actually creating the problem in this scenario. Another point is machines do everything better. For example, before deploys were done in a way that one person will start deploying the application, a person will set up downtime, and no one else can deploy at this point, and the deploys were manual. So machines do it better, there's no errors. From our development operation perspective, we give our development team a chance to maintain and refactor their deployments. And of course, as I already mentioned, there is no UI. You can just run one command and the whole thing will be just working. So how do we automate? Where do we start? Let's take the real example. The goal is for us to give our development team with a single command run the whole thing. Means scaffold the new project in any language. It has to be provisioned on CD tool. You can pick GoCD, Jenkins, or any other tool of your choice. Your code should be checked out, checked in from your source code. You run all the tests, your unit tests, integration tests, acceptance tests, and all the tests you need. And your code should be deployable in every environment. Why this piece is important is there is a simple explanation. Basically, we chose to have multiple environments as development, staging, and production. Development give our developers opportunity to deploy their code first time, to see how it goes, to see how it interacts, to see how it behaves as a single unit. That's the step when they all run the tests. And at this stage, we're trying to catch all the possible bugs, if possible, in a perfect world. If not, then it will just go to the staging environment. Staging environment for us runs in Kubernetes cluster, and it's a much more bigger scaled environment. Then we actually see how our application performs in a bigger world. We run the same tests, and then we can push it to production. So if I have a working Python code, how do I start? What do I do? Here I give the example of a very simple case scenario when you have your app, could be a Flask started by Unicorn. You have your database, you obviously have some static assets, you have a web server, and this all runs on the single server application. But I don't think this is scalable, because once you have many users or many applications talking to this kind of architecture setup, you will feel that single server is not enough, and you probably start thinking of building something like that when you have multiple application servers running the same Flask code, right, powered by the same unicorn. You will have some static assets in this case, and the database server will be the same. I also want to point out that this example is Flask application, but it can be any language. You can apply it to any other application frameworks. Could be in Python words, Django. I chose Flask because it's the one I know. It's easy to set up, and it's pretty straightforward in this case scenario. So once you start to going back of the puzzle, how do you deploy it? How do you test it? That's the architecture we kind of proposed. Basically, the black services are the ones you care about. That's what you're delivering. That's what you're talking every day, and they have to be tested. The yellow ones, those are can be just solution or third-party things that you don't have to test, that probably you will be just paying for them located in your cloud solution or things like that. So how do you approach this scenario with the part we just talked? So basically, we're going to pick the deployment pipeline, which is proposed by continuous delivery. And in this scenario, we're just going to break the whole thing in this kind of steps, which will be build and test. In Vevo, we actually have build, test, and push. We're using Docker Hub for push, basically pushing all our images before they go into the next stage. So the way it's going to look like, you're going to build your binary, you're going to test them, and they will run in something that we use here at Vevo is containers, Docker containers. And then we have this image that we will push to some registry, right, where the next pipeline can pick it up, run it, see how it deploys, then run all the tests. Then we do the same thing for our staging environment and obviously the production. So what is continuous delivery pipeline? This is kind of abstraction, and we suggest every team or every person who's trying to set it up for their own company to decide what they're trying to achieve with every stages. So basically, we try multiple things. We try to make stages very complicated because the way it's structured, you have a stage, you have a job, and job will run particular task. At Vevo, we use makefiles, which is very easy to set up. They are run on every environment. So basically, once you design your stages the way I showed in the previous slide, you can basically achieve all these kind of things. What it also gives you, let's say if you're one of your stages, basically it separates development team from DevOps team. We give them that tool, and they can see how deploy is happening. So I don't have to worry about the things like, is this stage passed, or do I notify the particular person who just checked in? Given those options, we know what stage actually failed, what actual job will fail, because makefiles are easy. You have different targets. So what you do, you wrapper your targets into the tasks, and you assign all the tasks to a particular job, and then you decide which stage should run what job. So if we go back to the slide 9, that was a slide, and what we decided to do, we wanted to scaffold new project. Basically, as I said, could be any tool. Then we decided to check out from source code and then run tests. I'm not going to show tell what kind of tests you guys should use. I'm sure every company have their own set of tests, their own setup. But the thing I want to point it out, they should not be part of like one environment. They shouldn't have like some configuration with dependent on environment. Basically, the more independent your tests are from environment, that means your application design more right. Because imagine when you have abstraction level and all your services are talk to each other, right? And the way you have to think, you should not depend one service on another one. But you should still guarantee the contract. Basically, when they talk to each other, you need to think, how do you design that contract between two services are working, that you get some response from other services. You probably at this point will not care if response is correct. So the part of the response should be done on the first stage, which was build and test and push. And then we deploy to every environment. So at Vevo, we propose these kind of tools, and that's what we use. As I showed before, it's a Python application. We use GitHub for our source code management, but it doesn't matter because you can script anything you prefer. I think if you cannot script, or if you're really dependent on your source code management, you're probably thinking of moving if there is no other reason for that. We chose to use GoCD just because we already have it. We used to use Jenkins, but Jenkins didn't have the approach of pipelines until 2.0, but it was a little bit too late for us because we already picked GoCD as our pipeline tool. We did try proof of concept for Jenkins 2.0. I personally really like it because it improves on security, because there is a possibility of using your Jenkins file, and the same concept applies. You can just script your Jenkins file, come up with something which applies like for entire team or for a particular type of the services, and you can just script the whole thing and apply to your continuous delivery, to your pipeline, and then just spin up and run the deploy. We use configuration management tools like Ansible and Terraform. Right now, we're actually trying to Terraform GoCD, which is kind of interesting project. Jenkins, I think Terraform doesn't have it, but you can try to. What we do, like if you never use GoCD, I'm not sure, have anyone used GoCD here or heard about that tool? So I'm gonna quickly describe what it is. If you guys use Jenkins, do anyone use Jenkins? Okay, cool. So you probably know the Jenkins concept of slaves. And in the past, it was a really, really big problem because they were disconnecting as if you have to run like very heavy stuff, and it was really hard to SSH into those agents. So basically, GoCD, it's a server, and it has multiple agents. And the benefit of running pipelines with that in every stage of your pipeline, you get in clean agent. So basically, there is nothing installed, right? So your container, in this case, Docker container, will install the whole dependency, all the things you need. That's why it was very useful. Now Jenkins 2.0 seems to have the same thing. And I haven't used it, but I heard it's the thing to consider. If you guys are already on Jenkins, you can try that and let us know. So as I said, we use Docker containers. We pick Docker Hub as a registry. I cannot say that Docker Hub hosted is a great solution. I would prefer if anyone creating their solution use params, because let me put the example here, then Docker Hub had a downtime and you cannot do anything about it. All your services are down, you cannot deploy. In this kind of, we have a huge wheel when people just check in their code and just gets deployed, right? In this kind of scenario, we have a lot of things just down, and recovery was really hard as well. And we run all our things on Kubernetes. If anyone uses Docker Swarm, Azure, or something else, they should just work, because basically, I'm not going to cover how do you set up your management cluster, things like that, but I'm sure it's all automated, or it should be automated. It should not be one monolithic thing. Or just try Kubernetes, it's pretty cool. So at this point, I'm just gonna go through this kind of slides because, as I said, it's a workshop, and we're not going to cover the way of how to set up the cluster, how to write the Docker files, and that's why I will just show the logic. As I promised on slide 9, that with one command, development engineer should be able to run the whole thing and just be happy about it. So here I give example as my application. This is how I name my project or my service. And I just pressed enter, and we'll see that there is some things happening in the background. This is Terraform. I can add that we also use Slack. I hope all of you guys using some kind of like notification system that let you know if your deployment failed or something went wrong. Because like for us, we don't go and check 243 of all our microservices, how are they doing. So the way we set it up, we add every Slack channel to the team, and they basically get notified if deployment went down. We actually have notifications sometimes per stage, like for a web, it's very important because the way it's architectured. So basically here you can see the process went through. There was a step where branch was created. It's all Terraform, and this is on the GitHub, so Terraform gives you ability to actually provision your GitHub repo. There could be some things with permissions. You have to just work it out and keep your security things in mind. And then in the end, the user will get the GitHub repo link, and obviously they can set up the Slack channels and stuff like that. So if I clone the GitHub repo, what we will see there is going to be a basic skeleton of the kind of pattern we created at Vevo that every team can start with. Every new hire can start with. Any developer in our company can just go and have this already set up for them. What is this? It's a Docker Compose. It's a makefile, as I said before. And this is the resources. What is resources in this case? As I said, we don't want to use UI. I don't like UI. And I haven't met any good continuous delivery tool with great UI that I will just like it. No. So what I would love to do, I would like to have a file which I'm actually know where how it's structured, right? I know the schema. I know what does it mean. So basically, I can just go and I can make changes to it without clicking UI. It's a couple lines of my code. Just go check in and be happy about it. But for the GoCD, for the current solution we're talking about, we have two files. One is the environment. One is the pipeline. Environment is just the way GoCD is structured. Basically, you have different environments. You can set up different environments for different teams if you want to add different, for example, like environments variable or use different AWS profiles or something like that. And then you have your example. So this is get provisioned automatically on the GoCD side, so no one went and no one clicked. Basically, if your pipeline actually clickable, how they call it, you will have some kind of setting icon there. If it's all in your GitHub or source code management, this is what you get. And if you ask me why this last step didn't run, because the way how good it is that, for example, I want my production step to be manual. In this case, you can just click on that button and the production part will just run. So based on that, this is what got generated. So we wrote our own tool which does that for us. It creates the application. You can see the application name on top. That's what I provided was application. Slack channels are empty, and then the group is infrastructure, and you see GitHub repo get added. There are stages. I give example of one stage because actually for every stage it will be more, and I'm not sure it will fit on the slide. And then, as I said, there are some tasks. There is a job, there are tasks, and you have some environmental variables in case you need them, which I will be not suggesting, but some test environments sometimes need them. So here we go, the pattern we're trying to achieve, and this is the model we're trying to propose. Basically, let development people write their code and test it. Let's set configuration in your SCM code manager, basically your entire pipeline. You do build, publish, and push your code to repository, Docker repository, or anywhere else. And then you have your 3 stages, 3 environments. Is there a way to improve this kind of solution? Yes and yes. Basically, what we learned and that packaging and dependency management in Python is not perfect. And one of the problem we found for us, there is no private repository when we could deploy our code officially provided by Python. There are other things like dependencies between libraries, and sometimes it's slowing down when you install something and the new version doesn't work. There is no, still, like, even if I try Jenkins and I try GoCD and I try Travis CI, and I'm familiar with Circle CI, and I guess there are others, I'm not happy with both. First thing, what we had in GoCD, sometimes agent just disconnects. Sometimes they all idle, right, but job hasn't started yet. So we try to talk to community of GoCD, it's an open source. They kind of slow in replying. Same, like you could, there is also, like, if you use Jenkins, there are tons of plugins. Sometimes, like, one of the reasons we not really like it because you have like 5 plugins. You go research them, not all of them working, or some of them outdated. So it's kind of slowing us down. And of course, security flows, as I mentioned, different setup like environmental variables and auth things, not perfect. So if we could find a solution better, or if there is something on the market that give it to us, it would be just great. What improvements everyone can make in their own company, basically create your own working skeleton. So don't try to use this pattern and just like, okay, I'm going to take all my microservices and my modules and just do that. No. So what we started doing, we started analyzing how they all look like. Are they related? What are simple things we can probably avoid, or what is easy to repeat? So what they end up doing is noticing that basically every team trying to build their service in a certain way. So we just create one working skeleton for every team. Some images can be reused, like Docker images, like module dependencies. If you guys have your own NPM or Python modules or Java libraries, they can all be reused within your company. Test scripts the same way. What we also did, we provide standards. All types of our application, like Java, Scala, Node, Python, they all have NFS standards, and we try to make sure that all of the services, all of the applications run in a certain way and have certain specs. So basically that's what I wanted to tell you. So the quick summary, if make sure or try to make sure that everyone can deploy at any time in your company, so people don't have to come at night, or there should be no downtime. Make sure the development team responsible for what they build and they can run it. Moving forward faster, which means no one get blocked. Everyone can deploy at the same time. No one has to wait for everyone. No one is dependent for anyone. And automation is usually better than manual, just because it's faster and saves our own time. Thank you so much for your time, guys.
So, any questions?
Okay, thank you for your speech. Just wanted to ask if in which cases should we not start doing continuous delivery?
I guess you should be doing it in all the cases.
What about costs of, so how many time, how many money should I spend for starting doing continuous delivery?
So the thing is, as I said, because it's all goes, like our GoCD runs on Kubernetes, right? So let's say you can create some analytics tool which checks if your agent actually idle and you don't need them, you can turn them down. So we have this analytics in place. We can cover it more, but basically, if your agents are idle, they don't have to run on your infrastructure, right? So if you have logic in place, you take them down. Also, as I said, there should be a pattern that all of them are similar. So you don't have to spin up this. For example, there could be architecture, then you don't have to have deployment in your pipeline. You can just skip it and add something like unit tests into your build process. I probably will agree with you if you have, well, I understand there could be a startup kind of company, but I don't think they will have that many of microservices in this case. So,
one question I have is, let's say you have 100 microservices and you have only one staging cloud, staging environment. So everybody wants their changes deployed to staging all the time. So how do you how do you make sure that, it's fast enough, your testing is fast enough? Like with so many changes coming in for all the 100 microservices.
actually, that's the case, that you have one staging environment. As I said, all the small things, all the bugs, okay, most of the bugs should be checked and deployed to your development, right? If you use Docker Compose, you can spin up like small local services, right? Like your database, for example, I know Redis, things like that. So that all has to be already done on your local machine, or you can use some other instance. And then staging environment is it's like copy of your production. Basically, before you go to production, you want to make sure, like, you don't want to check something to production and get surprised, right? That's why staging, it's best case scenario if you can make it as your copy of your production. I'm not talking about scale or load, but like the same services, the same third-party things if you can use, which is actually probably not very cheap. But if you want to do it right way, that's the way, how we do it at least.
So would you track the version mismatches? Let's say I'm developing microservice A and you are developing B. We both have changes, but I pull from master and I only have whatever you push to master, and you also have changes. How do I make sure that those are?
So if you use microservices, they don't have to be all at the same version at all the times, right? And as I said, there is a contract, if you heard of the term, which used between the services, which again you run on your development part, which what it tests or what it gives you, that you make sure that contract between your services is working. And the same step should be work on the staging. I can give you an example. For example, I am service A, and I'm talking to service B, and I get something from service B like, hello, and the service will reply, hello, I am service 2, right? So that could be your basic contract test, that I get my reply and the payload, or you can even test type of the payload, and you can go further. But if I didn't get anything, I will not deploy it to staging, right? Because something is broken. The contract between my services is broken. So that's the way of making it secure. Secure meaning not breaking your staging and production environment.
Hey, thank you. Could you expand on kind of when you first implemented this, kind of like how many days and what did you build it around? What did you test it with? Like how broad did you go and how long did it take? And what was like the first like big problem or big benefit you saw?
So the first problem, why we start even thinking about it, because before we have, obviously we had big monolithic app, and then we have a lot of .NET apps. So when we start refactoring those apps, and at the same time we start moving to Kubernetes services, right? We noticed that it takes a lot of time, and it's really painful to go through each service, maybe refactor it, maybe not, to check if there are tests. So basically what our approach was, first thing, to define, as I said, can we remove some service? it's all start from architecture. That's why I start this presentation from architecture. You need to think, what do you want to do? Then you can see how many services actually are okay or match your standard, right? And then if you see, for example, some of the services could be repeatable, then you have to go through the logic of your APIs. Does this service do something different than that? How they are dependent? When all this done, then you, I'm skipping the part when you're actually choosing the language and all these things, right? And for example, at Vevo we have, just give you a quick example why it's so crucial for us. We have all the clients running, like web, iOS. We have 13 TV different clients. We have all the airlines clients, like it's a lot. And on top of it, we have data services, which is totally different. And we have SDN services, right? So for us, it was a big, tremendous change. And how it improves, let's say if you move in between the teams or you need to fix something with another team, or you want to just move to another team, you don't have to go through the pain of learning how they do deploys. So you basically start the same project, the same skeleton, right? Then just pick up, you probably know what, and you modify mock files within the team. So your targets are the same, but the way how you do it is basically on the team. But obviously we can help with architecture, how to make it like less costly, things like that. Did I answer your question? I just can talk more, but I don't know.
Hey, so I have some questions regarding, so you mentioned Docker Compose. If I have two applications which basically run on the same environment, mine is the cron tab, and the cron tab basically gets copied over at Docker file time.
Can you lift it up?
I'm sorry, can you hear me? Okay, so if I have two applications which basically run in the same environment, the same Python version, same libraries, and it all gets built during the Docker build process. The only difference between these two applications is the cron tab, which gets copied over at build time during Docker. How can I have and the actual container is brought up during compose time? So how can I have it where the cron tab is brought up at compose time instead of at the Docker build time, so I basically don't have to publish two images for basically the same environment?
So let me understand. You have a service which uses two different Docker files, Docker Compose files.
So exactly, it's one Docker file that we commit as like an example file, and it copies over a text file as a cron tab, and it copies it over to a directory within the container. But the thing is that these two applications, they have different cron tabs, and when we deploy it, we only want to deploy one cron tab in the container. So how can I make it where I can basically have the cron tab be copied over at compose time instead of at the image time when building the image?
So I might still understand. So basically what you do, like the way how I would do it, I would not have two compose files. So you have one.
There's one compose file, but
right.
Yeah,
and
yeah.
the way you run your Docker file is through your Docker Compose, right? So you do all
Correct.
this services setup on that level,
Yeah.
and that to your Docker registry, you get a Docker image, which actually gets published to your.
Right, that's already being done. My
Okay.
question is specifically with the cron tab. How the cron tab runs within the Docker container. So the
What
cron,
does your cron tab does?
it runs a sequence of shell scripts which run Python scripts. And it's basically, it runs it every hour.
So
But
then-
both applications have different cron tabs, but they both have the same environment.
Both applications run different cron tabs. How do you run your cron tab on, let's say, on AWS, on the Kubernetes?
It's
Basically,
run-
it's going to be one job, right?
It's run within the container, so the cron tab is brought over to the cron directory within the container. It's copied over locally into the container when you build it. The issue is that these two applications, they have different cron tabs.
So you just set them up? I'm not
I don't want the containers to be running two sets of cron tabs, in other words. I want one container.
Can you set something like some variable would just run them at the same container but in different time or something like that?
See, that's the thing. It's I don't want both sets of jobs being running within the container. I want to separate it out. So basically, I would deploy one container on another host that would run that specific cron tab, and on another host which would run the other.
Understand. I would do it separately, but that's a good question. I will. I can email you back, but I didn't have this architecture in my mind before.
I have something to contribute. Data scientists have been running into this problem that cron might not be the best way to go. So there's a package from Airbnb called Airflow. Airflow allows you to schedule dependencies in Python, and then you can commit those, and you avoid all these kind of conflicts. So if you deprecate cron and move to Airflow, you don't have to worry about that.
Yeah,
Okay,
that's a
interesting.
good.
Thanks, man.
That's actually our data team uses. Thank you. That's.
Cool. Thank you.
We also have Kubernetes cron job. It's a new thing, but it's really cool.
Any more? Yeah. So I've got a question quickly. You said you don't like UIs, and I agree. But nobody at my company will use continuous deployment or anything like that unless it has a really pretty UI.
Oh.
How would you, which means I have to become a front-end developer. So how would you persuade them otherwise?
No, you have a UI. You can still look at it, but as a development or like development engineer, I don't want to use it. It slows me down.
Mm-hmm.
If my manager wants to look at it, it's still there. I didn't take it out. So they can go and check it, but I don't have to interact with it. That was like one of the main goals. And CLI is faster.
Mm-hmm.
No arguments.
Cool. Well,
One more question over here. Thanks again for the talk. Did you research any on-premises, what was it, let me see, it was Docker Hub that you guys were using and that wasn't working very well. Did you research any alternatives potentially for on-premises?
The only thing we found, what I found, was just run. You can set it up locally. It's not hard, but just we don't want to, like it has to be a separate instance and we have to maintain it. So probably it has to be something on premises, but if there will be like already a solution, like you can just provision your EC2, we would go with it. But we don't want to like build the server and then manage it, and if something goes wrong, like what happens and something went down, things like that. So my answer is no. That's why we're still with Docker Hub. That's reality.
Okay.
any more? Yeah.
I mean, so a recommendation there, I'm a huge fan of GitLab because it unifies both the Git, CI, CD, and also the Docker registry in one. And you can either use their hosted solution or we use an internally hosted with about 700 developers. So I'm a huge fan of that for unifying exactly what you're asking.
GitLab. Thank you. Cool. Oh, we'll check it out. Anyone else? Okay, I guess there's
Thanks.
snack time, so you guys can have some. Thank you so much.